Welcome students. Welcome again to my new lecture. I am Muhammad Tanvir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh.
Measurement of yield of underground sources. The yield of an aquifer is estimated by the following two ways. One is on the basis of flow velocity of the groundwater, and other is by performing pumping tests in the field. Estimation of yield on the basis of flow velocity of the groundwater. If a well is penetrated through an aquifer, the water will rush into it with a velocity. Assume that rushing velocity is v, and the area of the aquifer opening into the well is A. Then discharge will be Q equal to V into A. As we know, discharge equal to velocity into area, where V equal to discharge velocity into the well, and it can be calculated using equation NVA, where this N is the porosity of the soil medium and VA is the actual flow velocity of groundwater. If we replace V equal to NVA in equation 6.1, we will get V equal to Q equal to NVA into A. Actual flow velocity of groundwater VA can be estimated by using Schlichter's or Hazen formula. According to Schlichter formula, actual flow velocity VA equal to K prime into I into d square 10 divided by mu, where VA equal to flow velocity of groundwater in meter per day. K prime is a constant, I equal to slope of the hydraulic gradient line, d10 equal to effective size of the particles in the aquifer in millimeter, and mu is the viscosity of water, which depends on temperature. According to Hazen's formula, the actual velocity Va can be calculated using equation Va equal to K double prime into I into d square 10 divided by 60 into 1.8 t plus 42, where V equal to velocity of groundwater flow in millimeter per day, K prime is a constant, T equal to temperature, which will be in degrees Celsius. There are two constants used in these two equations. One is K prime, which is used in Schlichter's formula, and K double prime, which is used in this Hazen's formula. The values of K prime will be 400 for Schlichter's formula, and K double prime is 1000 for Hazen's formula. It can be better to measure groundwater flow Va in the actual field by using chemical tracer, such as dye, or by using electrical resistivity methods. The time taken by colored water to pass a certain distance will be noted, and from this data, velocity can be calculated. If t is the time taken by a chemical tracer to travel a given known distance s between two observation wells, the velocity can be calculated by using equation Va equal to s divided by t, where s is the distance between two observation wells and t is the time taken by a chemical tracer to travel this distance s. From this test, we can calculate the value of k. As we know from Darcys Law, the velocity v equal to k into I, and from here we can calculate k equal to v divided by I, and again we know v equal to nva, which we have seen in slide 3. So we can get v equal to k equal to nva divided by I, where I equal to HL by S, where HL is the difference of water surface elevation of these two wells and S is the distance of these two wells. Darcys Law. According to Darcy, the groundwater rate of flow or discharge through soil is directly proportional to the head loss HL and area of the cross section A of the soil, and inversely proportional to the length L of the soil sample. So from this law we can write Q proportional to HL into A. As in this law, the discharge Q is directly proportional to head loss HL and cross-sectional area A, so we can write Q proportional to HL into A. And also in this law, the length of the soil sample L is inversely proportional, so we can write Q proportional to 1 by L. If we rearrange this equation, we can also write Q proportional to HL by L into A. Also we know HL by L is the hydraulic gradient I. So we can also write Q proportional to I by A. We will just replace HL by L as I in here. If we use a constant of proportionality K in this equation, we can also write Q proportional to KIA, where K is the proportionality constant, which is also called permeability or coefficient of permeability. The unit of this K will be centimeter per second. Here is an example. Let's read the question first. Find out the velocities of groundwater flow with the following data using Schlichter's and Hazen's constant as 400 and 800 respectively. So we have to calculate velocities of groundwater, that means VA. Here Schlichter constant is 400. We know Schlichter constant is K prime, so K prime will be 400, and Hazen's constant 800. We know Hazen's constant equal to K double prime, so the value of K double prime will be 800. Viscosity coefficient mu of water at a groundwater temperature of 10 degree Celsius equal to 1. So we can write the value of mu equal to 1. Effective size of particles in the aquifer is 0.1 millimeter. So we can write the value of D10 will be 0.1 millimeter. Hydraulic gradient, that is I equal to 1 by 80. First we will calculate the velocity using Schlichter's formula. According to Schlichter's formula, we know velocity Va equal to K prime into I into D10 square divided by mu. Here the given data are mu equal to viscosity coefficient equal to 1, I equal to hydraulic gradient equal to 1 by 80, K prime equal to coefficient of permeability for Schlichter's formula, which is 400, and D10 equal to effective size of particle is 0.1 millimeter. If we replace all these values in equation 1, we can calculate the velocity according to Schlichter formula. Here this is the Schlichter formula, and we have just replaced these values here in this equation which we have got in our previous slide, and finally we get velocity Vi equal to 0.05 meter per day. Again from Hazen's formula we know velocity Va equal to K double prime into I into D10 square divided by 60 into 1.80 plus 42. Here T is the temperature in degree Celsius, which is given in quotient is 10 degrees Celsius, and K prime also given in quotient as 800. All other values will be same as Schlichter's formula. So if we replace here all these values in this equation, we can calculate the velocity Va equal to 0.1 meter per day. So these two are the velocities based on Schlichter's formula and Hazen's formula. Here is the another example. Let's read the question. In a field test, a time of 6 hours was required for a tracer to travel through an aquifer from one well to another. That means the value of time t is 6 hours. The observation wells were 42 meter apart. That means the velocity of S is 42 meter. And the difference in the water levels was found to be 0.42 meters. That means the value of HL will be 0.42 meter, and this is the difference of water level between these two wells. Compute the discharge velocity. That means we have to calculate velocity V. the coefficient of permeability K given the porosity of the soil medium as 20%. First we will calculate the discharge velocity. Here given in the question, the distance between two observation well is equal to 42 meter. Porosity of the soil medium as 20%. Here given in the question 20%. Time of travel of the tracer t equal to 6 hours. We know velocity of groundwater flow v equal to n into va. Again we know this groundwater velocity or actual velocity va equal to s divided by t, where s equal to 42 meter and t equal to time 6 hours. So we can calculate va equal to 7 meter per hour, which is 0.194 centimeter per second. If we convert 7 meter per hour into centimeter per second, we will get this value, and the conversion process is here. Now if we replace all these values in equation 1, we can calculate discharge velocity v equal to 0.0388 centimeter per second. Now we will calculate coefficient of permeability K. From Darcys law we know v equal to K into I. From this equation we can write K equal to V by I, where I equal to hydraulic gradient between the wells, which can be calculated using equation HL by S. Also, HL equal to difference of water surface elevation of the two wells, which is given in question as 0.42 meter. S is the distance between two observation wells, and it is also given in question as 42 meter. So we can calculate I as 0.01. Putting the values in equation 2, we can calculate the values of K or coefficient of permeability as 3.88 centimeter per second.
And that is the end of our today's lecture. Thank you everyone.